Today I'll be discussing the de Broglie wavelength and its contribution to quantum mechanics. To begin, we have to know, who is de Broglie? Louis de Broglie was a French physicist who was born in the 19th century in Dieppe, France. He was originally interested in philosophy, but after influence from his older brother Maurice, he enrolled at the University of Paris and began to study science. He is best known for his hypothesis to explain the theory of atomic structure in 1923, where he declared the particles have properties of waves. Now, I'll be talking about the background of the hypothesis in a little more depth. So, prior to the hypothesis being developed, the image of the world at the start of the 20th century was very different than the way it is now. Diffraction was only believed to be a property possessed by waves. Matter was thought to have a significant mass and to be tangible, which means anything you can feel with your hands. The tangible matter was thought to be made of atomic elements that exist close together. But radiant energy, such as X-rays or light, are waves, which means they are spread out and not close together. Waves also do not exist at one point, proving they do not have a significant mass. So, de Broglie stated that waves pass through barriers similar to how sound passes through walls. For example, if an atomic nucleus releases a piece of itself through alpha decay, the particle does not have enough energy to overcome the barrier that surrounds the nucleus. But, as a wave, the particle can go through the barrier and can be found in the nucleus. Therefore, de Broglie's hypothesis states that matter has wave and particle properties. It also says that the wavelength is inversely proportional to the linear momentum, p, of the particle by h over p, where h is Planck's constant. De Broglie also found that in an atom with an electron, in order for the wave to have a stable amplitude, the number of wavelengths needs to fit in the circumference drawn by a Bohr orbit. At the time the equation was derived, there was no experimental proof, but this came in 1927 by two scientists named Lester Germer and Clinton Davison. They proved de Broglie's hypothesis. This was done using a nickel crystal and an electron gun to diffract a beam of monoenergetic electrons. The diffraction pattern was the same as X-rays, demonstrating the wave nature of matter and its relation to the momentum of electrons. De Broglie's hypothesis further led to the development of quantum mechanics.